All right, so we're going to look at this function, and we're going to do some evaluating here. We're going to name some things. We're going to find domain and range, evaluate it here, figure out all kinds of stuff. So we're going to be looking at weird-looking functions and identifying pieces. So the first thing we're asked for here on this first graph is our domain. What might our domain be on this one? Yep, from -3 to 5. And putting this as an interval, are we going to put brackets or parentheses? Brackets. -3 to 5. As far left as it can go, as far right as it can go. If it helps you, you can think of it like this. -3 to 5. That's my domain. What is my range going to be? From -2 to +2. From my low point. Ooh, that is wonky. From my low point to my high point. So as an interval, we're going to go from -2 to +2. Again, they're both endpoints. They both have closed circles. So they're both going to be brackets. So we've talked domain and range before. We've seen those a gazillion times, but it's nice to kind of check in again. Now, feeling okay domain and range wise? Cool. So now we've got this F parentheses 1 close parentheses. We used this kind of notation yesterday. What do we do with something like this? What is this trying to tell us? Y is equal to f of 1, right? What is the 1? X. Why is that? X equals 1. So what is the y value when x equals 1? 0. It's this guy. So f of 1 equals 0. F of 1 is my y. Just like f of x is my y. He's just in disguise. Function notation is just, he's got a cheesy mustache on. Trying to be sneaky. He's not sneaky, but he's trying to be sneaky. Okay, so D is very similar, but also kind of not. So now they're saying find all x's such that my f of x is 1. Where's that going to be? What does this piece mean? Where y equals 1. Because we just said f of x is just y in a mustache. Like he's in disguise. Cheesy disguise. So what x values have a y of 1? Yeah. So we typically write them smallest to biggest. So if we think of the places where my y equals 1, I've got -1 and 0.5 and 2. So when we're writing this as our interval notation or writing in our sets, we're going to put our set bracket on either side of it. Squiggly bracket. What this is having us identify is where our function crosses the line y equals 1. That's what it's looking at here. Where our function crosses that line. And it's at -1, 0.5, and 2. Okay, so questions on that piece? Okay. The last one is also kind of weird. So all x's such that f of x is greater than 1. What is that gonna look like? What does this mean? Y is greater than 1, greater than 1, right? We want where Y is greater than 1. What's up? It is, in fact, greater than 1 there. Is that every place that it's greater than 1? Because isn't that yellow line 1? Where is my function, my black line, above the yellow line? This space and this space, right? We're going to write our x's as intervals. I need everything above the 1. So we're going to write those two pieces as intervals. How do I write this left one as an interval? Where is that? Think about your x's. Where is it starting? Where is it stopping? What is the left endpoint? Goes from -1. My x value is -1. And it's going to go to, where does it stop being? 0.5. If I set my interval with a closed bracket and we say exactly equal to, will that be greater than 1? Or is that when it exactly equals 1? Does this point right here exactly equal 1, or is it greater than? Exactly equals. So is that included if I say when y is greater than 1? No, it's not included, but I can get real, real close to it. So we're going to put a parenthesis. How about on the 0.5? This is also right when it equals 1, so we can't include that. So that one is also going to get a parenthesis. We're going to do a very similar process for this other piece. I'm going to pick a different blue for. So that one. Just so we can have things that are similar colors. Where else do we have our y's greater than 1? What other interval? Remember, we're labeling it by our x's. Where does it start? Because 0.5 is where the last one ended. So it's starting here. So our smallest value on that interval is going to be that 2. And where does that interval end? At 5. Is my 2 included in here? Or does 2 make it exactly equal 1? It's equal to. So is 2 included or excluded? Excluded. If it is excluded, we put a parenthesis. Because if I look directly at this point, this exactly equals 1 right here, and I need it to be greater than 1, not equal to 1. How about our 5? Is the 5 included or excluded? It is included because 5, 2. 5 is above 1. So if it's included, bracket. So our space that has all x's such that our function is greater than 1 is the interval from -1 to 0.5 unioned with 2 to 5, with 5 being included. Questions on any of these? Because they're a little weird and they're a little awkward. But it is what it is. Okay? Let's look at our next graph then. That's all we're doing on this graph. Our next graph is the one that kind of looks like 2 U's, mostly. So we're going to find our domain, our range, and then we're going to state some intervals. Let's hit the silent switch on our phones. We don't be using our phones anyway, and we're keep thinking like we have an idea. So we're going to start with identifying our domain and our range. So I'm going to start with identifying our domain. What is our domain going to start at? Negative 5. Is negative 5 included or excluded in our domain? Included. Because it's got that closed circle. If it's included, we put a bracket. Where do we stop for our domain?
6.
Do we hit every value between negative 5 and 6? I was going to say, because we stop at negative 2, and then there's a little gap. So I can't just plow through. I never have an x value of negative 1.5. Like, there's just nothing there. It's a big old gap. So we have to go until our segment stops. So where does this segment stop? Negative 2. Is negative 2 included or excluded? Excluded. So we're going to put a parenthesis. So that gets me through that first segment. Where does my next piece start? Negative 1. Because we have this gap between negative 2 and negative 1. Is negative 1 included or excluded? Included. When it's included, it gets a bracket. Where is the next place that I have to stop? At 2. Is 2 included or excluded? Included. Where do we start next? Positive 3. Is 3 included or excluded? Excluded. And where does that segment stop? 6. Is 6 included or excluded? Included. So this has 3 intervals that we are going to union together. If there's gaps in your domain, leave a gap in your intervals. So then let's look at our range. What do we think might be going on with our range? So there's definitely something happening with that negative 3, right? Because negative 3 is in our range. I've got y values of negative 3. But it's not intervaling at all. It's just negative 3, right? For this little segment down here. So when we have something that's like a horizontal line, we're just going to list those horizontal lines. In this case, I only have the 1. So we're going to put it in our set notation, just like we did for our x's on the last one. Our negative 3 is a part of our range, but it's not connected to anything. So we put it on its own, in its own little special bracket. So that's our bottom segment, guy. What is the next piece where our range starts? Negative 1, the lowest piece. Is negative 1 included or excluded in my values? Included. Where do I stop having y values? I was going to say, this segment stops at 3, but do I still have y values even at 3.00001? Yeah, I still have y values over here. So where do we stop going up? 4. Look at our y's. And 4 is included. So again, if you like to think about them as like individual segments, our range would look like this. That's our range just done as like a number line over here. And our domain would go from here to here, here to here, here to here. So that's what those would look like as separate pieces. Orange is domain, red is range. So if it helps to think about it that way, you absolutely can. Okay, so on our, especially piecewise functions, domain and range can look a little wild. But questions on those two pieces? Okay. Because the next thing we're going to look at is some intervals where it's increasing, decreasing, or constant. So I'm going to start with things that are increasing. And all that means when increasing, we talk about things that are increasing, is they're going uphill. Think positive slope. They're climbing. When we read from left to right, because that's how we read words, I'm looking for things that are going up. So where do we have pieces that are going up? From 3, -1 to 2, 0. That's a piece that's increasing. When we talk about our intervals, we talk about it in terms of our x's. So we almost never list things in terms of y's. So, except for range, that's it. So I want to see this interval when it is increasing. Where does it change from decreasing to increasing? What x value? -3. Where does it stop increasing? At -2. When we're talking increasing and decreasing, at this point right here, the place where it changes direction, it doesn't count. That is called a point of inflection. That is not a word that we need to know off the top of our head, but it doesn't actually change there. So we do not include the place where it turns in our increasing interval. So we're going to put parentheses on this end. And since our -2 is an open circle, it doesn't count anyway, so it also gets a parenthesis. Where else do we have an increasing interval? Between 4 and 6. Here, it's going up from here to here. So our other increasing interval is going to be what? From 4. Is 4 included or no? No. Is 6 included?
Yeah.
Yes. 6 is still increasing. It's a closed point and not at a change in direction. It's not going to be a huge deal on those things. Mostly we're going to be given intervals and sketching. All right, then let's look at our decreasing. Very, very similar. So instead of looking for things that are rising, we're looking for things that are falling. Think negative slopes, going down. Where are we decreasing here? Between -5 and, oh, wrong color. -5 and -3. So we're going from -5 to -3. Is our -5 included? Yes. Is the -3 included? No. Because that's where it's turning. The place where it's physically turning does not count as increasing or decreasing. Technically, it is a slope of 0 right there. What other interval do we have that is decreasing? Between 3 and 4. Are either the 3 or the 4 included? Neither one, because the 3 is an open circle and the 4 is where it turns. And then our last piece on this one is to describe where it is constant. What do we think that might mean? Straight line. So this is going to go from -1 to 2. Are -1 and 2 included? Yes. Okay, so constant is straight across. Decreasing is falling, increasing is rising, right? Looks kind of crazy, but not awful. Okay? Questions on this one?
Wait, so the
Yes, dear.
brackets are for not included? I mean,
Bracket is included. Parenthesis is not included. Okay. Because more often than not, we're not really going to label intervals as increasing or decreasing. But I might give you intervals. We're going to have to draw when things are increasing or decreasing. Oh my gosh. Ah. So we're going to be sketching a graph that is increasing when it's on negative infinity to negative 3, and it's increasing from 2 to infinity, and it's decreasing between negative 3 and 2. And I gave you guys a little graph for this, and I know it's very small, but obviously it was a matter of how many pages we were printing out for everyone to use. And mine's a slightly different scale up here, but that's okay. So what I'm going to do is I'm going to take these intervals and I'm going to give myself some like visual barriers. Not asymptotes, but I'm going to graph them very similarly. So I'm going to look at the interval between negative infinity and negative 3. So I'm going to draw myself a vertical line at negative 3. Because I know something's going to have to change somewhere around here. Because I need this side to be increasing. That's what it says. This side is increasing. I also need from 2 to infinity to be increasing. So I'm going to draw myself another little line at positive 2. Like this. And again, you don't have to draw this, but it does help when we're doing stuff. Because I need this interval to also be increasing. And then when it's between, so my negative 3 and 2, in between them, this is going to be decreasing. I'm just going to put, bless you, D, just because I'm running out of space. And they don't give us any other information than that. So creative choice, driver's choice, just make sure we are increasing in our increasing section, decreasing in the middle, and then increasing again. So probably the simplest thing to do is, all right, we're going to start. I know it's going to have an arrow over here because it says all the way to negative infinity. And we are increasing. When I hit that wall, I'm going to turn, and I'm going to bring it down. And then I'm going to hit the wall, and I'm going to turn, and we're going to increase. So it is increasing from negative infinity to negative 3. And it is increasing from 2 to infinity. And it's decreasing in the middle. And it's just a sketch. We don't have more information than that to make it more specific. Just sketching. That's all we're doing on the sketches. That is sketched. Done. We're going to do another sketch because these are a little awkward. So I've now given you 2 intervals for each. We've got decreasing from negative infinity to negative 2 and from 1 to 4. And then we're increasing from negative 2 to 1 and from 4 to infinity. So I'm going to draw myself some little barriers. I'm going to set this one as my dark blue this time, from negative infinity to negative 2. And if you guys ever want colors, I have a gazillion and a half colored pencils, markers, highlighters, whatever you need. So if you ever want a color code, you absolutely can. But I'm going to draw myself my little barrier at negative 2. And I know that this section needs to be decreasing. Capital D. It's decreasing. I know that kind of looks like an O, but that is in fact D for decreasing. And I'm going to put my interval for 1 and 4. So I need 2 walls on that one. So at 1, I'm going to have a little wall. And at 4, luckily yours are all numbered. Mine's not numbered. And in between those 2 little walls, we are still decreasing. Between negative 2 and positive 1, so in this space right here, it's going to increase. And from 4 to infinity, so this guy over here, it's going to increase. See all those little pieces right there? Questions on any of the pieces? All right, so decreasing, we're going to start by falling. So we're going to drop it. We're going to increase, and you can increase as fast or as slow as you want. And I'm going to decrease. Then I'll do a significantly slower increase here. And it has arrows on either end because it's going out to infinity. What's up? Mm-hmm. Oh, so like you talk about like x-intercept? If I don't give you that information, it doesn't matter where we put it. So it's always a good idea to go back and make sure we've done it right so that we've got our decreasing between negative infinity and negative 2. I am decreasing between 1 and 4. I am increasing between negative 2 and positive 1. And I'm increasing between 4 and infinity. So it matches back up to what we were told. So it's a good idea to go back and double check it. But that's all we're doing with those is we're just kind of sketching them out. So we're starting to get the vibe of these. Because we're going to start playing with polynomials. And making wiggle squiggle grass. And doing all kinds of fun things with them. Yeah. Okay, we're going to have that one more graph, that last one. And I know it's small, but I'm going to have a bunch of questions about it. But this is the last one. Okay, and then when we're done with this one, if we have questions or want to work on homework, oh my gosh, we'll have a little time once we get through these. Sorry, lots of them. And, oh, I love that. It played fun games with my formatting. Because all of those were single line before, so that the size was not quite so gross. Ew. That's gross. All right. So our first one says to find f of 0 and f of negative 6. So look at your graph. I'm going to see if I can make this be a little less gross up here. I'm going to switch the screen for just a second so that these all wind up being significantly closer to a single line. There we go. Okay. Less gross. I know still gross and still a bunch of questions, but less gross written like this. Because they're not 2 lines anymore. So we're just going to write things out. So our first thing is to find f of 0 and f of negative 6. So what is f of 0? It is a lot. This is going through a lot of the things we talked about today. What is f of 0? Positive 3. My x is 0, so it's this guy right here. Y equals 3. Less. So then the other one for that question was f of negative 6. What is f of negative 6? Negative 3. This guy down here. Okay. Well, we kind of used it yesterday when we were doing the equations. It's okay. So then our next question asks, what is f of 6? Careful. Negative 0.5, negative 0.6. I'm not petty like that. If we don't have the information to get it close enough, we're just going to take it as close as we can. Negative 0.5 is fine. How about for f of 11? Equals 1. Because that's this guy on the end over here. So then they're going to ask us a couple of kind of strange questions because they like to be a little weird. Is f of 3 positive or negative? Positive, because it's way up here. So f of 3 is positive. That was this guy right here. Is f of 4, or I'm sorry, is f of negative 4 positive or negative? Negative. That's this guy down here. My y value would be negative, so that was going to be negative. Okay. For what values of x, so we're going to have a list of x values, is f of x equal to 0? Negative 3, because my y is 0. Where else? Positive 5 and positive 10. So my list of x values is like this. We put our squiggly brackets because x is the set that contains those values. Or you can list them out. X equals negative 3, x equals 5, x equals 10. Either way is fine.
Wait, Miss Mary.
Yes,
So for the third one, I thought we were looking at like the f equals y. So why is it negative 5?
So for the f of 3, right? That was the one I'm talking about?
No, f of 6.
Oh, f of 6. So f of 6, so our x is 6. X is 6. Y is negative 0.5.
So you look at the x value? Or
So the number inside your parentheses is our x. They replaced our x with 6. So when x is 6, our y is negative 0.5. Okay. Cool up to here? All right. So the next one they're asking us is for what values of x is f of x greater than 0? Where is it greater than 0?
1, 2, 3, 4, 5.
It's an interval. Everything above, ooh, that's trash. Let's try that bigger. Everything where my function is above my x-intercepts, that's where it's greater than 0.
So 3.
So from negative 3, is negative 3 included or excluded? Ooh, if we have to be greater than, exclude it. So from negative 3 to 5, included or excluded? Excluded. Any place else? From 10. Ooh, does it go to infinity? Where does it stop? 11. Is 10 included or excluded? Excluded. Is 11 included or excluded? Included.
Oh, so what's on the line is because it's on 0.
Correct, because then it would be equals to 0, not greater than 0. So I've just did that in orange, and then I've just started it down here so we can find it later if we look at the PDFs. What is our domain of F? What's our domain? What is it? -6 to 11. Both of which are included. Domain is our x values. So from -6 to 11. What is the range of F? From -3 to 4. Included on both. What are the x-intercepts of F? -3, 5, and 10. We've already written those once. The zeros are the x-intercepts of F. Yes, dear. The very highest place that it goes. Right there. It's a lot. See that? Okay, cool.
This is probably going to be one of
This is not the quiz. This is section 3-4. This is section 3-4. This is not for the quiz for tomorrow. Yes.
tomorrow.
It has literally been on the calendar since I handed them out.
I make that, no, I forget.
No, I never once did.
I forget the
Thursday, September 26th.
I see and I forget now.
And Thursday, September 19th are the two quizzes. I handed this out to you on Monday, September the 9th, and it's been on here since then. All right, lock it back in. We're almost there. Y-intercept of F. What's our y-intercept? What's our y-intercept? 3. It's in fact our f of 0. It's the point 0, comma 3.
Correct.
So then they have some weird questions they love to ask us.
How often is the y?
Like, how often does the graph cross the line y equals 1/2?
Twice. 3. Oh yeah.
I was going to say, when in doubt, sketch it there. The line where y equals 1/2. Oh, trying to make this a little bit darker there. It's going to be kind of here-ish. How many times does it cross?
3.
How many times does it cross?
3.
1, 2, 3. It's like we're very confident, but also make sure we're checking it. How many times does the line x equals 5 intersect the graph?
1. Once.
Okay, draw in. Oh, x equals 5. Yep. Sorry, my brain went y equals 5.
Once.
X equals 5. That's vertical. Wrong space. Positive 5.
Yeah.
Just once.
Once.
For what value of x does f of x equal 3? Which values? X would equal 0 and x would equal 4. For what values of x does f of x equal -2? Just -5. For what values of x does f of x equal 5? Not 0. 0 equals 3. For what values of x does f of x equal 5? It's not up there, but I'm asking you.
F of x equals 5.
For what values of x would f of x equal 5?
F of x.
5.
Not 0.
Wait, what?
None. It doesn't ever equal 5. You don't have to have a number. Your answer can be no solution. All right, we've got 2 minutes left. If you guys have any questions on like past homeworks or anything, we can talk through some. I'm going to take a screenshot of this real quick. So if you have questions, let me know. I'm happy to talk through some. We got a couple minutes left, but that is what we're doing today. So if you got questions, let me know.
Can we use calculators and then on the quiz no calculators? It's like a lot of the
On the homework?
Yeah.
I'm not watching you.
But some of them are like way too complicated.
I was gonna say, the textbook